I must apologise for my eye there. Had a bit of a collision. It actually looks a lot worse than what it really is. There's a bit of bruising there. I had a word with the makeup department, but they said no, it would be too much work. And in any case, the rest of your face needs work on it as well. Well, I thought, how rude can they be? Anyway, we're going to talk about random wire antennas. Now, random wire antenna, well, it suggests that it's completely random. I mean, random means anything, isn't it? So you can put up a wire, a random wire of any length. That's what a random wire antenna is. It's got to be, isn't it? Random wire, any length, it will work. Well, actually, it's not quite as random as the name suggests, because there are certain lengths which you have to avoid. So when we talk about a random wire antenna, we actually don't quite mean random all the time. Confused, isn't it? Well, that's the purpose of this video. We're going to take a look at the random wire antenna. Now, days gone past, we used to call it a long wire or an end-fed wire. Not a random wire. Long wire was the term that I grew up with, and we didn't really know what to do other than make some sort of matching unit. We used to measure the amount of current or the signal strength. We didn't have VSWR meters. We had a term saying tune for maximum smoke. Yes, that was what we used to have. We had a long wire tuned for maximum smoke. Well, things have progressed a bit more now. We're a bit more civilised now, and we talk about the random wire. And indeed, the random wire is quite popular. So let's take a look at the random wire antenna. One of the reasons that I chose to produce a video about the random wire antenna is because quite a few stations are using them now, and I've had one or two emails from mainly newcomers asking various things about the random wire antenna, particularly what is the best length for a random wire antenna. Bit of an anomaly, isn't it, really? And because there's a lot of stations either using them or wanting to use them, I thought I'd try and cover it and pass on a few tips, a few hints and tips. Now, I must warn you that there are a certain amount of those that will really rise up against any antenna that's end-fed. The end-fed antenna, whether it be a random wire antenna or an end-fed half-wave, will cause you lots of interference. You'll get lots of noise and you'll cause interference. It's really a bad choice. That's sort of comments you'll get. Well, actually, I think there's enough end-fed half waves about now, and indeed enough random wire antennas about now, to prove that that really is not a valid criticism of that antenna. It has potential, and the good thing about the random wire antenna, of course, is that it will fit into various gardens. It'll fit into a long garden and a short garden. You just adjust the length of the wire, bearing in mind that you have to avoid certain lengths, which I'll come to in a minute. And basically it will cover a lot of bands. It is in theory possible to have a random wire antenna that will cover 160 through to 10 metres and work quite well. The 160 metre performance may be a bit limiting, but it will be okay for local contacts. On the other hand, if you've got a long garden, or indeed bend the wire around the garden, because that's one thing you can do with a random wire and an end-fed half wave, you can bend them around the garden. They seem to be fairly docile. They're fairly tolerant of being bent. So potentially the random wire antenna has a lot to offer. It will fit into your garden and it will cover quite a few bands. So let's now see what a random wire comprises and the sort of theory behind it. The basic random wire antenna comprises a length of wire, surprise, surprise. It has a length of coax in order to connect the end of the wire to your transceiver, and at the point where the coax would or does connect to the end-fed wire, we insert something known as a 9-to-1 UnUn. In other words, it's got a ratio of 9 to 1. And the 9 to 1 UnUn really is the key to getting your random wire antenna to perform adequately and do the task that you want it to do. What's the difference between a random wire and an end-fed half wave? Well, there is quite a bit of difference. First of all, an end-fed half wave has to have a precise length. It has to be at least a half wave, or precisely a half wave length on the lowest frequency, and it then works on its harmonics. It needs a 49 to 1 UnUn, and if you insert the 49 to 1 UnUn between the end of the wire and the coax, then you get very good performance on the lowest frequency, and all the frequencies harmonically related. So if you put up a 40 metre wire, in other words a 40 metre half wave, which is 20 metres of wire, put up 20 metres of wire, put a 49 to 1 UnUn at the feeder end of it, then connect coax, and that antenna will work on 40, 20, 15 and 10 metres, and you'll get a very low VSWR, very popular antenna. But it doesn't work on the walk bands, and it is therefore a bit of a problem if you want to operate on the walk bands. If you want to operate on the 17 metre band or the 12 metre band, it doesn't really work that well. In fact, it doesn't work very well at all. So there are some downsides, but let's hope that our random wire antenna will fill in the gaps, because that's what we wanted to do, don't we? In simple terms, the way that a random wire antenna system works is that it works on the principle that you should be able to get a length of wire that presents a medium impedance on a number of ham radio bands. Now, the transceiver expects to see a 50 ohm load. Quite clearly, with a random wire, it's not going to be 50 ohms anywhere but perhaps one or two spot frequencies, and I wouldn't suggest you connect an end-fed wire direct to your transceiver. If we accept that the normal load is 50 ohms and the end of a wire can be anything from, say, 60, 70 ohms right up to 3,000 or 4,000 ohms, if we can find a point, a medium point. Now the medium point can be something like 450, 600 ohms, 700 ohms, that sort of thing. And that's a sort of impedance we get when the antenna is about a 3/8 wave long. We get that medium impedance. And that medium impedance can be repeated on several bands. So if we accept that we can get a length of wire that presents a medium impedance on a lot of bands, and then transform it down to 50 ohms, we've got the basis for our random wire antenna, and hence the 9 to 1 UnUn, a ratio of 9 to 1. What it does, it wants to see ideally 450 ohms at the end of your wire, and then transfer it down to 50 ohms. That's the perfect situation. It probably won't happen at all, or maybe on perhaps one or two spot frequencies. But it is possible to get lengths of wire which present medium impedances, and those medium impedances can range from, say, 400 to 600, 700, 800 ohms. But the 9 to 1 UnUn will transform it down to a much lower impedance, and the transceiver can handle much lower impedances. So we are looking for a length of wire which will give us a medium impedance on a lot of bands. We're going to take our 9 to 1 UnUn, connect it to the end, and the output of that UnUn is going to give a much lower impedance, one that the transceiver is quite happy to work with. So let's now sketch out the basis of a random wire and how it all fits together and how it works. This is our random wire, and then here we fit a 9 to 1 UnUn, and then we have a coax cable going back down there to the transceiver. That coax is 50 ohm, and we'd really like to see the end of that wire present an impedance of 450 ohms. 9 times 5 is 450, or 9 times 50 is 450, hence the 9 to 1. So we've got the wire there, we've got the UnUn there up in the air, and then with the coax cable any length back to the transceiver. With random wire antenna, it's important to understand when we're using this 9 to 1 UnUn that not only is that part of the antenna, but also the outer sheathing of the coax is the part of the antenna as well, because RF current flows on the outer sheathing of that coax as well as flowing on the inside of the coax. RF floats on the outside of that coax, and that becomes what we call a counterpoise, and that is actually an essential part of the antenna system. Let me just redraw this so you can see the concept of the coax cable being part of the antenna system. So we've got our random length of wire, we've got our 9 to 1 UnUn, and then we've got the outer sheathing of the coax coming down here. Now that's almost like a dipole. One half of the dipole is that length of wire there, the other half of the dipole is the outer sheathing of the coax. Quite clearly, the length of the wire and the length of the coax is almost certainly to be different. So we're actually feeding this dipole, if you like, off center. And because it's off center, and if we get the dimensions right, we can get, I don't like to call this 450 ohm because it's not 450 ohm, we go all over the place, but what we want is a medium impedance there. We don't want it to be high, we don't want it to be low. We want that impedance to be medium. And that is the complete part of an antenna system. This part radiates, that part radiates as well. And that's basically the concept of a random wire antenna. Now if we go back to our original drawing with a random length of wire there and the coax cable there, and we already said that that outer sheathing of the coax radiates is going to have RF on it. So it's essential that outer sheathing, that RF on the outer sheathing doesn't reach our transceiver. So we need to insert at that point there an RF choke, and that's really essential. An RF choke must go there. Very easy to make an RF choke. We use a ferrite core. You get yourself a ferrite core, that's the core there, and you just wrap as many turns as you can get of the coax around that core before it goes into the transmitter. You need a larger core for that in order to get the turns around there, and generally speaking you need to use something like RG58 coax there. In fact you can use RG58 all the way up there. You'll get a little bit of loss on 10 meters, but it's not significant unless you've got a long length. If you've got a long length of coax, you want to use thicker coax, then you're going to have a junction there and go to the last bit of RG58 before it goes into the transceiver. But I would suggest RG58 around that core, and if you've got a long length of coax, okay, go for something a bit thicker. It's entirely up to you. But the main point is that you do need an RF choke there to stop the RF energy going down to the chassis of the transceiver. That's quite important to have that fitted there. Now we've got the principle of the random wire antenna in our heads, let's talk about the length. There are a number of lengths that would be computed which should be ideal for a random wire. In other words, they are not multiples of half waves on any bands. And I'll put below this video now on the screen here the lengths that have been recommended. One of the most popular lengths is 71 feet. I don't know why it's well, I suppose it's popular because actually it's been proved to work quite well, and with that length you should get 80 through to 10 metres, and it's also a length you can fit into a small garden, because bear in mind that you can bend a random wire length of antenna around the garden, and it seems to work quite well. 71 foot is quite a popular length. Generally speaking, the shorter lengths in my experience, don't work that well. You do need something a bit longer, and I would say if you can squeeze in 71 feet, then that would be a good starting point. Do bear in mind, of course, that these measurements may not be exactly right for your garden, because like any wire antenna, the actual correct length is determined by how high it is above the ground, whether it's bent round the garden, whether you've got trees, poles, whether it's near the house, etc, etc. All those things affect it. So 71 foot, if you choose the 71 foot length, is a good starting point. And if you find that things aren't working out quite well, then try lengthening it or shortening it. In fact, it's far better to have the wire slightly too long and then trim it back. And in fact, you don't need to trim it back, you just bend it back on itself, and you should find that you get fairly good results. Now I'm going to come on to actually matching VSWRs and that, because there's a few myths there, so I'll discuss that now. With a random wire antenna, we've achieved what we set out to achieve, actually, to get a low impedance back to the transceiver. But it's not an ideal. There's some reactance there. It's not ideal. And what you must do is you must use an internal, well, not internal, you must use a matching unit in order to deliver power to this antenna. In other words, if you've got a matching unit in your transceiver, fine. You will need to press the tune button in order to match the antenna. Now I've heard some people say, oh, I've got a 1.5 to 1 on all bands with my random wire antenna, but when you make further inquiries you find out that actually what they're doing is they're telling you what the VSWR is after they've pressed the ATU button, or the matching unit button on their transceiver. In my experience, you're going to get VSWRs of 2 to 1, 3 to 1, even 4 to 1 on certain bands. But that really doesn't matter, because your transceiver will probably match those reactances, that sort of VSWR, and the loss you get is actually very small, even at 4 to 1 VSWR. The actual loss caused by that VSWR is very rarely more than about a dB, which is neither here nor there. Maybe on 10 metres it goes up to about 1.5 dB, unless of course you've got a really long coax run. All coax cable of course has got a loss anyway. You can't get away from that, so you're on a level playing field there. But with the random wire antenna, you're going to get a VSWR which is going to vary probably between 1.5 or 2 to say up to 4 to 1. Most transceiver internal matching units will match that. And what you've done is you've achieved what you set out to achieve. You're actually delivering power into that wire antenna, which will radiate. So that's the basic principle of the random wire antenna and the essentials. If by any chance you don't have an internal matching unit in your transceiver, maybe you've got an older transceiver, then you will need an external matching unit in order to match the antenna. But by all accounts, from a lot of people I've heard of recently, it works surprisingly well, and it could well be the answer to needing a simple antenna in a smallish garden that you can bend round the garden. So that's my take on the random wire antenna. Now I always find antennas fascinating, and just before I finish this video, I found on the internet today Palomar Engineers, a website, and I'll try to remember to put a link down below, and I'll put up on the screen now an antenna which they have I think they've just launched anyway. They claim it's new, I think. And it's quite an interesting antenna because it's basically an end-fed antenna, and it's 27 feet long. Yes, 27 feet long, and it covers all bands from 20 through to 6 metres. In other words, it covers 20, 17, 15, 12, 10 and 6 metres. And it's only 27 foot long, which is quite interesting. It uses a 4:1 UnUn at the feed point, and then you have a set length of coax cable, which I think is 7 feet. I'm saying from memory now, but you'll see it on the screen. 7 foot of coax cable. Then you insert a choke, and then you have whatever length of coax cable you like back to the transceiver. And that again is another example where the outer sheathing of the coax is used as part of the system. It radiates up to the point where the choke is. Anyway, you might want to take a look at that antenna. It's quite an interesting one, and I mean, I've no experience of it, but Palomar Engineers have been going for many years, and I suspect that this probably will work as they claim it will work. There we are. Anyway, thank you for watching this video. Thank you for supporting this channel. Don't forget to press the subscribe button, because it does alert you when there's a new video coming up. And we usually publish 1 video a week, sometimes a bit more than that. Depends on whether we've got the time and what we've got to talk about. And by the way, when talking about it, it's quite interesting to actually get your comments, because some of the comments actually are the springboard for further videos. So please provide your comments and ideas, and they are all read. I don't respond to them all because there are so many of them, but I do read them. There we are. So you take care, enjoy your ham radio, and I'll look forward to seeing you in the next video. Bye for now.